Welcome to the Digital Enterprise Society podcast, addressing all aspects of the digital enterprise, inspiring connection without boundaries and creation without limits. Thank you for tuning in. Here are your hosts, Thom Singer and Craig Brown.
Hey, you have found another episode of the Digital Enterprise Society podcast. Thank you so much for coming along on the journey of this show that is almost 2 years old, that we designed to be a resource for those who work in and around PLM. The Digital Enterprise Society is a forum for the exchange of ideas surrounding the tools, processes, and practices used across the product lifecycle. To learn more, visit digitalenterprisesociety.org. My name is Thom Singer, and I have the honor to co-host this show every week with Craig Brown. Craig is an industry veteran and former PLM leader at General Motors. Hello, Craig.
Hey, Tom. It's good to hear you. Good news. It's still March, and I got flowers blooming. It won't last. They'll get nipped before long.
Well, we like to see spring peeking out. That is for sure. We had that little freeze in Texas a month ago, and now we're already chasing 80 degrees.
Well, we haven't that far. 70s one day, 60s otherwise, and it's going to get cold and rainy again, but that's normal for this time of year.
Awesome.
So anyways, yeah, here comes the sun and the spring. And, we talk sometimes about the pandemic a bit, and right now I'm kind of holding my breath. Things here are a little less good than they were a couple weeks ago. So we'll see. And I hope we get through this.
You got your vaccination, though.
I did. And I had a few side effects, and now I'm pretty much over all that. So I'm not in the, it's great to be able to say that people 60 and over are not part of the next wave. So that's kind of cool, right?
I got my first shot. I'm waiting for the second one. So then maybe I can go out and speak at some live events again before the year is over.
I hope before the year is over for sure. I'm shooting for the fall. So we'll see.
Hey, Craig, we have a guest today. Maybe we should interview him. Maybe we should get to the guest. Craig and I tend to talk a lot up front, but we actually have a great guest today because every single week, Craig and I try to bring to this podcast interesting interviews and other ideas that are going to help all of our listeners enhance and grow their careers. And today we have Bob Van Til, and he is the Pawley Professor of Lean Studies and Chair of the Industrial and Systems Engineering Department at Oakland University. Hey, Bob. Welcome to the Digital Enterprise Society podcast.
Thanks, Tom. Great to be here today. And congratulations on soon-to-be birthday number 2.
Yeah, we've been doing this show now for 2 years. We have interviewed some really interesting people all around the industry, which is great. So, Bob, can you do us a favor before we get started and give us a little bit of your background?
Sure. I am been at Oakland University for a long time. I joined basically 1984. Prior to that, I got my degrees, undergraduate, graduate at Michigan State University, undergrad, and Northwestern University for graduate school. And spent some time throughout that working at General Motors, process engineering in the Grand Rapids area of their diesel equipment division plant. And spent a little time at Northrop also, doing the more hardcore engineering work. Went to Oakland in 1984 and really haven't looked back. There's a lot of change over the years. A lot of things grew and changed and developed. Spent some time overseas in Australia and the Netherlands, and also in Hawaii teaching.
So when we were talking before, one of the interesting things I thought when I was asking you about your background, you said that part of your job is to lead the team of faculty to be really relevant in today's world. And having been in academia a long time, what have you seen around like trying to make sure that you and your team are actually cutting edge in 2021?
One thing we do is put a real focus on knowing what's going on in industry and keeping connected with industry and having industry involved and getting that feedback, knowing that 99% of our students will spend their careers out in industry as engineers with, at most a terminal master's degree. Our purpose of our program really isn't to replicate faculty or academics. A small portion of our students will go, but 99+% will be working engineers, and we really want to make them relevant to what they need to do.
So, Bob, thanks for being a guest. And, I interacted with Oakland, and I had my assignment before PLM on simulation methods. And at the engine group that I was a part of, internal combustion engines, we had a couple professors from Oakland that were helping us with new simulation methods. We were part of it was about lubrication, so tribology, and another part was about just machine dynamics. One of the first questions. Let's help the audience understand a couple things. First, when you say process engineering at General Motors early in your career, I think you mean manufacturing processes. Am I right?
Correct. That's right.
And we say, could you repeat your answer again?
Well,
we'll edit it a little bit.
Equipment division. Okay. Diesel equipment division was a manufacturing of high precision products. So we built diesel fuel injectors, hydraulic valve lifters. We were just preparing a new manufacturing plant actually for fuel injection for the gas engines. Was when GM was moving from carburetors to throttle body injection. And so we were just building a new plant for actually building those. This is the late 70s, and we were running EDM in mass production. We had laser welders. We were friction welding. This plant was an amazing place back in the 70s.
So that's interesting. And so then the next question I wanted to ask you is, well, when did you first use computers to simulate phenomena that you were then making decisions about your engineering? I mean, was it then? Was it 1970s or was it some other time?
Oh, not in the 1970s, actually. I spent a little time in tool design, and we were on a drafting board. At that time, we didn't even have a CAD system. That actually came a little later. I did a little bit of work. My background is more control theory, and I did some work at Northwestern, developing some programs that would do very crude simulation of control systems. But back in the late 90s, as I slowly drifted more from control theory to manufacturing, we put together a project with one of the OEMs in one of their manufacturing plants in Detroit, where I was based it after something called model reference adaptive control, where you build a controller to run a physical system, and at the same time, you run the controller against the model of the system. And if the two outputs agree, everything's fine. But if they don't, the system changed, and you go and you try to update it, the model to correspond to that. So now I can change the controller to control the model. Kind of bad idea. And so we decided, let's apply that to a manufacturing simulation. So let's go into a plant, look at a framing line, 65, 70 machines in the body shop, and build a simulation. They claimed at the time to have data, computer downloaded data that we could use to run the model. Of course, in the late 1990s, the data just wasn't there. But basically, when we were doing digital twin work back in the 90s, our proposal was, let's build a digital twin, automatically maintain it against the physical system, and then use the twin to do what-if analysis and make prediction stuff about the system. But the data just wasn't there.
So that's pretty cool because, most everybody hears digital twin today, and they think it was something somebody invented in the last 5 years. And, that isn't the case. We didn't get to the moon back in the 60s without some notion of a digital twin, the very thing you were describing about adaptive controls and being able to have a reference model that you use. And then as you collect some measurements, you can update the model. I mean, that was really done by a bunch of control theorists in the Northeast as they were building guidance systems, right? And guidance systems for spacecraft. So it's really interesting. Well, you mentioned also that you wanted to be relevant, and your department name is interesting to me, industrial and systems engineering. A lot of people don't combine those two phrases, and I'm kind of curious, what was it that spurred you guys and the department you head to focus that way?
Well, we at Oakland, we actually have a long history of systems engineering. We've been offering degrees and programs in systems in a long time. All our undergraduate engineering programs, mechanical, electrical, computer, and ASEE, the students take a core program together as a group. And so it's like 21 credits with topics like CAD, programming, digital analog circuits, thermo, Raman stats, statics.
And how long have you been doing that?
And we've been doing this all along since I was at Oakland. I mean, we revamped the core over time, but all our students go through that same 2-year core as a group to get a little bit of all the engineering before they really go into their majors by junior year. And then in our department, we also require courses in systems engineering. So our program our undergraduate program actually is one of 6 in the nation that's ABET accredited in both industrial engineering and in systems engineering.
Yeah, and that's really important. And I hope that, the term system engineering is overloaded by a lot of people, especially the tool vendors and the consultants. But this notion of being able to understand other disciplines, so you're trained mechanical, but you appreciate electrical, or those aero guys that do fluid dynamics and controls, right? Getting able to bridge all those domains is really important. We talk a lot about systems engineering today and being needed for the newer, more complex products. Well, part of what makes them complex is because we've got a really cheap computer down inside of it that's able to sense and adapt, right? Just like the adaptive controls you talked about earlier. So system engineering is becoming a lot more important. Do you have guidance or a way you describe it to your new students so they don't get confused what we mean when we say systems engineering? Do you have maybe a precise definition of it?
Yeah, that's interesting because I agree with you. Systems engineering has kind of been the throw with all name in academics. I got a robotics program. I got a mechatronics program. I got a whatever. It doesn't fit under mechanical, electrical, whatever. They tended to be tagged as systems engineering. And actually, that's kind of being changed because ABET is changing the criteria for systems engineering. But what we do is we think of it as more like what the INCOSE definition of systems engineering. So if you think of requirements planning, the V, you got all these different domains, like initially you design very component level. Now you got to learn how to design system level and how do you coordinate all of that. And so the classic thing to use out in the industry would be the V, the systems engineering V would be kind of a lot of people when they hear that would say, oh yeah, I know kind of conceptually what you're talking about.
Yeah, but it's good you come from a car industry background, because one of the shortcomings of INCOSE, at least this is my view, is this ability to understand a product line and manage a product line. So in other words, a kind of a car and the different variations of that car that you're going to sell in the marketplace, and being able to manage the systems of cars or the system of a single product or the whole manufacturing process that enables all that in one plant, right? Those are all different ways of looking at system engineering. And INCOSE, at least the founders way back when, it was all about how do we build that next defense system that's really complicated, but there's only one of them, right?
No, I totally agree. The concept is kind of there. We deal with informs, we deal with a lot of different groups. And the auto industry is really interesting because, again, as I mentioned, systems, as you mentioned, has that strong background in defense and in aerospace. And auto always kind of said they did it and kind of did, but they didn't get real serious because they didn't have the level of connection between all the systems that they have now. And they're discovering now that, boy, everything is connected to everything now. And they're really upping their game on systems engineering.
Well, I think, part of what I've noticed, and I think it's part of what drove Oakland, the way you guys have evolved, combining industrial and system engineering. Well, it was about systems theory, systems practices applied to a plant. How do you make the plant more efficient, right? High quality products, but still efficient. And so part of this sensing and adaptive process is really tuned to manufacturing. Well, of course, the car companies did that really well. They had to stay in business, right?
Yeah.
So then you find out your systems engineering experts actually have the manufacturing background, and they were the ones that drove computer-aided everything, right? From design to simulation to even process planning back to manufacturing. How you lay out a plant and how do you make sure the layout's the best one for what you're trying to do?
Yes, I agree. For a long time, industrial systems engineers deal with complex manufacturing systems or supply chain systems or whatever. There's a lot of actually complexity, and you need those system tools to handle those kind of things. And so that's kind of where we made sure we integrated systems with industrial when we formed the program. We actually launched the program in 2007 to go with our existing engineering programs. Basically, we had a manufacturing into our program. We were trying to upgrade that. We looked around to how can we make that a relevant degree program rather than the product courses. And industrial was a brand name. And when I looked at the numbers, it kind of surprised me. In the United States, in 2019, there are 4 main domains of engineering, each with around 300,000 engineers apiece. And it's mechanical, electrical, civil, and industrial. And then it goes down to about 80,000 aerospace engineers. There's like a magnitude drop. And I was really surprised at those numbers. It's the second biggest domain in Michigan. There's about 3 times as many industrial and systems engineers as there are electrical engineers in the state of Michigan.
Well, yeah, it's because of the mechanical manufacturing footprint, right?
Yep.
So once you begin to see the motivations, so a little bit different than the order I gave you. The Europeans, especially the Germans, came up with Industry 4.0, and it kind of is the same theme about applying systems engineering practices to the whole Internet of Things, meaning cheaper and cheaper sensors on your line that can give you feedback on how your line is performing and maybe preempt a failure and be able to keep your plant running. Do you see we need the same thing here in America, the Industry 4.0 kind of initiative, or is it just happening because we're naturally competitive?
Well, it's just happening. It's been happening. Our program actually was doing Industry 4.0 before that term appeared. I mean, we were doing it back in 2008 or 9. We were doing the things that later got tagged as Industry 4.0. We were using the name PLM because it fit as part of the PLM life cycle into the kind of the manufacturing part of that circle. I see, concept, design, engineering, manufacturing, around the life cycle for PLM. And we fit within that structure of that. Industry 4.0 basically kind of took that section and said, we're going to call that Industry 4.0 now, the manufacturing part. But we started that back then, and it led out of the PhD student who did the project I mentioned earlier on trying to build a digital twin back in the 90s. By this point in time, he had graduated and was working with one of the PLM companies. And he contacted me as we're forming the department. We're talking to a lot of industrial people about what we should do. And he said, you guys got it. These digital tools are taking off. And because of the Ethernet and what we now call IoT, we can get the data that we couldn't get then. You guys got to put these in the program. And so that's kind of started it from our day one. We tried to embed some of these tools and concepts, digital twin, Industry 4.0 into our program.
So some of it I've noticed is the resistance in organizations to embrace it is this idea that sensing is inexpensive or becoming cheap. It's a commodity, right? I can add a pressure or a video or a temperature sensor anywhere, or even a vibration sensor to see if there's a milling problem going on. And before that used to be, thousands or tens of thousands of dollars to buy it and another 2 months to install it and tune it and all this other stuff. Now it's just happening. So I'm kind of curious, the younger folks, a lot younger than I am, they're used to growing up with a Fitbit. So they're used to being sensed and measured all the time. And when they come into a university program like yours, and then maybe a cooperative education like at a car company, are they going to be able to push these organizations, or are they're just able to adapt to everything you're talking about? And Industry 4.0 might be a cute buzzword to them, but to them, that's like, you mean we haven't been doing this all along? Because everything's easy, right? Easy in terms of financing it, right? It's no longer these special measuring devices that you got to go spend a lot of money on.
Oh yeah, I mean that's the key. The data is there. The tools were there, although they were cruder back then. But the data is there now. That was the thing that was always missing, and now you can readily get that. Now you can really take advantage of the tools to do stuff. And our connections with industry have been super strong. I mean, they're coming and grabbing our students because they have these different tools and they know them. And it's been a great pipeline for our students out in the industry.
Well, so let's go back and talk about that for a second. So 20 plus, 30 plus years ago, as CA something, computer aided design, computer aided simulation, all of them, right? Big companies like the one I used to work for, they had these huge training programs that take people who were used to being on a drafting board and all the processes and reviews over the shoulder that you did there, and now putting them in front of the tubes, and you become a specialist at doing design. And then parts of the design job, like creating a certain surface or whatever, got automated by the tools, right? It seems to us now, or at least to me, the kids are getting this from you, right, at the university, or they're even coming equipped with it because they learned it even earlier, right? So I think where this training is being done on using computer-based things, well, anybody who grows up with an iPhone, they're probably used to it, right? And I guess that's my point is universities as well as companies have to be agile about who takes the initiative in this training. And I think the training's now squarely with programs like yours, as opposed to an individual industrial giant. The industrial giant's off trying to, well, in the case of car companies, build the electric fleets now, right? And they really don't want to spend time custom educating for a certain PLM tool suite, right? They're just assuming kids will know it, right?
Unfortunately, they would like the kids to know it, but what we're finding is a lot of universities are a little bit slow on the uptake. In fact, that's been to our advantage because...
Well, that's to your advantage, yeah.
Because they're just grabbing our students. They're coming to us. I early on, one of the things we did with industrial engineering, of course, is ergonomics and human factors. That's an important area. And we joined the Siemens academic program back in 2011 and brought in their I4O tools. And one of those tools would be Jack, an ergonomics tool. And we embedded that course in our program. And we put that tool into some different appropriate classes, and students can see it and play with it. And the feedback we got after doing that was from companies and our students and alumni were, wow, it's great, I know the tool, but I'd like to do a deeper dive into the tool if I go into ergonomics. So then we developed these half-semester applied courses focusing on a tool where you got 16 students in our PLM lab on each one on the computer, and they're using to do a deeper dive into the tool, and they're doing projects with it along the way. And so they kind of, in class, you don't really have enough time to really teach them the tool in detail. And now if they want to go down ergonomics or simulation or discrete event simulation or some path, we have a series of 6 different half-semester courses where the student can do a deeper dive into the tool in that area. Feedback we got on this, I talked to a senior manager at one of the OEMs that you are really familiar with early on, in one of the ergonomics people who they, and ergonomics is interesting because in Canada, you got a bunch of these kinesiology programs. And the big 3, if you go into any ergonomics group, you find all these Canadians. Yeah. And when we started, one of the other OEMs, one of the competitors to yours, actually said, you guys got to do ergonomics. You got to do more ergonomics. You got to put this in there. So we embedded that. We got Jack, and we did a good job doing that. The senior manager basically said, wow, it's great. You guys got a great program. You're doing ergonomics. And I'm like, well, I benchmark all the IE programs. You can't accredit it without ergonomics. What do you mean? We're doing ergonomics. Everybody does it. They go, oh, no. You guys do Jack. You guys use Jack. Your students do online stuff. Yeah, they're pretty good at it. 2 weeks ago, one person from that department, one of my alumni, gave a little what I do in ISE to my intro to ISE course presentation. And he basically said, basically our department is all Canadians or Oakland University students or graduates. They hire people out of Canada or people from Oakland University. And it's because of the tools we embedded the program. And what surprises me, and I'm starting to see traction on this, is more universities haven't embedded the tools deeper into their undergrad curriculum.
Well, I think, I've been in some interesting debates, and one of our chairs of the old PLM world, who's down at Purdue, you probably know Nate, but it was interesting. He invited me to some sessions at Purdue about this exact topic of bridging the academia silos, right? Mechanical, electrical, and who's responsible for ergonomics? Well, everybody should be, but each wants to stay in their silo, each their discipline of electrical or their discipline of mechanical. And so ergonomics, especially operator of machines in a plant, those folks benefit from systems engineering and the theories that come with that, right? The systems view of it. Repetitive injuries, I mean, to the credit of our friends to the north in Canada, they had better industry-wide government programs to encourage that, right? Worker safety and all that. Now, to stay competitive, all the car companies have figured it out now. And to Siemens' credit, and then they brought investment to that side of their tools. When Siemens acquired all these companies, Unigraphics and all the rest, that was a big thing they wanted to solve too, right? Is in the Siemens manufacturing plants, how are they making sure ergonomics are well addressed? So that's part of the benefit of tools like Jack and the others being a part of a big industrial company like Siemens. There's a benefit there. So
yeah, it's interesting because again, after we were doing this for a while using Jack, another one of the OEMs. Yeah, and the other two I mentioned, one of their head of their group came in and talked to students in one of our classes, and they noted that they had started using Jack a few years before that to do ergo analysis on anything worldwide in the manufacturing plant. And they saw like a 400% decrease in repetitive stress costs through workers' comp within like a 2-year period of doing that. They wouldn't release the job to a person until it had been analyzed and shown that there's low risk of repetitive stress.
Yeah, that was my point about our friends in Canada. The government was more on top of that before there was regulations here in the United States. But so this is interesting. So the students, do they aspire or come to you because of your program, or what's I'm interested in the students' view. How do they view your program, and do they naturally move to your department because of this success, or is it the rare student that says, oh yeah, industrial is where I want to be? Your numbers were really revealing, but do students, when they come to campus as a freshman or a sophomore, do they know they want to be an industrial engineer?
We tend to get a smaller freshman class. First year students is a smaller class, and we do some outreach to help do that. But we get a lot of our sophomore class is always much bigger. Because the engineering core, the students get to see the various engineering domains as they go through. And they can wait until like they're into their second year before they absolutely have to declare the major. I mean, you could be an ME from day one, and then at the end of year two, all of a sudden, I'm going to be a double E, and you're right on track. Because of the core-based program. And we pick up a lot during sophomore year. By junior year, we have a lot.
Well, that might have been a poor question. I mean, a lot of youngsters have an idea what they think their profession is. And then when they see, like anybody, if you walk into a modern manufacturing plant, it's rather amazing, awesome, right? In terms of what happens, the flow of material, the way things are operating, and especially if it's mass production like automobiles, it's pretty amazing. And so there's if you're an engineer at heart, there's some pretty interesting problems to solve there. And simulation, of course, just makes it that much better. So,
yeah, the simulation is big. The people side, of course, industrial systems engineering is more of a people side of engineering, and it's more connected to the business side. You'll see ASEE PhDs in business school faculty. And so we tend to get that person wants to be bigger picture, a little more people focused, maybe a little more business background, or the techie types who want to use Jack or plant simulation or process sim, those simulation tools on a bigger system and not just do a CAD drawing and simple. They want to see a lot of interaction going on. And so we get those two types of people.
Well, that's just the gamer finding a job that he can use his gaming skills, right?
Oh, yeah. And what's neat is the direction you go, and one of the reasons we started industrial is it's not just manufacturing. In fact, a lot of schools stick the systems on to emphasize it's more than manufacturing. Yeah. And so we place a lot of people in supply chain. With Hope Depot, Amazon, those Universal, those kind of companies. Healthcare students are going, the quality assurance people in healthcare are really industrial engineers doing lean. We do a lot of lean work. We've worked very closely with the Lean Enterprise Institute out of Boston, Jim Womack's Institute. We're the first academic university that they partner with for education purposes. About 3 years ago, they looked at all the programs around the U.S. and cold called us and said, you guys are the lead university in teaching lean in the United States. We want to partner with you guys to help the next generation.
It's interesting. We probably had, 10% of our guests are what I would call lean zealots, meaning they really get it. And they most all of them have a manufacturing background, but it's been all kinds of industries. From electronics to chemical to cars to aircraft.
We placed a couple of our people down at Disney in Orlando. Most of their Imagineers are actually industrial engineers in the background.
Well,
they're dealing with big system stuff.
Yeah. It's all about moving stuff, whether it's moving customers or moving the employees to where the customers are, right?
Yep. It's flow systems. And again, that is discrete event simulation, plant simulation is all about flow systems.
So for a moment, think about where you guys are going, and I'm curious what's the next evolutionary step in education for these kinds of skills. I mean, so people are doing more simulation, they're looking at flow. What's going to happen in the next 5 to 10 years? What's the next skill that we're going to embrace?
They need to embed these into their class and then start working with industry to do relevant projects with them. And so, we kind of do that in our senior design. We're lucky where we're located in Rochester, Michigan. There's a huge engineering manufacturing base surrounding campus. We initially started our senior design where, company give us a project and, maybe we'll have an on-site visit and then we work on it. And, once or twice the students visit. And then at the end, they present out their solutions. And getting feedback on that, the companies are always kind of like, that's a nice idea, but you can't do it because these 12 reasons. And I'm thinking that real world constraint link is missing. And so what we actually do now is we work with companies to develop 14-week projects where the students are embedded, a team or 2 or 3 are embedded in the company. They'll spend 5 or 6 hours a week at the company site. Right. Under a company leadership on a project being led by the company. And we don't charge for this because you're putting in sweat equity. When I teach that course, I'm a high-level project manager. And sometimes companies don't get it. And they kind of like, go do something, go work on something. It's like, no, you got a list of 28 projects you want done. You can do the first 7. Give us number 8. This is something that you guys want done. And so actually a supplier, one of the tier 1 suppliers across from the street from the university, has 2 my senior design teams this semester using Plant Sim to develop digital twins and to analyze different. One is an existing system to do what if, and the other is they got a new proposal for a system and they're building the twin and doing the analysis, trying to figure out if they should go with this new system.
Interesting. Well, so to all of you listening, those of you that have lots of skills, but need some new skills, or those of you that are just entering the profession and are thinking about what else you need to do, this idea of being on site with real problems and being able to take all of these digital tools and apply them, that's a really important thing. So, Bob, it's really interesting chatting with you. We could go a lot longer, but I wanted to ask you one point about the Digital Enterprise Society. So we do these podcasts. Thom and I have been doing, I think we're close to number 100, believe it or not. And I'm curious, what else would you like our members to do to encourage these kinds of programs that you're talking about? Is there something they should take back to their companies or something they should just give you a call? Yeah, get involved with universities. And I would personally, I would hope that you can put a little bit more pressure on other universities, get more involved. Everybody is doing it at a different rate. You might run into roadblocks and you might not. I would love to talk to anybody. We talk to people everywhere. We deal with people everywhere. We love making connections with companies. We consider them part of our community. I mean, it's faculty, the students, the staff, and industry companies. They're critical to our community. And so I'd love to hear from anybody. And speaking from my personal experience, I both as a student, long time ago, and then as one of those companies using students, our work with Oakland and building new simulation methods, and this is over a decade ago now, was really fruitful for everybody, not just the students and professors, but also for our company, right? We came up with new ways of predicting things. So thanks again, Bob. It's been wonderful talking with you. Thom, back to you.
Awesome. Awesome. Well, Bob, thank you so much for joining us here on the Digital Enterprise Society podcast. And thank you to everybody who tuned in and listened, because you know what? Why would we do this show if it wasn't for the audience? So please make sure you're telling your friends and getting more people to listen, and then join us every single week for more thoughts, ideas, and information in and around product lifecycle management. The Digital Enterprise Society is the place for the exchange of ideas around digital manufacturing tools. Go check us out at digitalenterprisesociety.org.
You've been listening to the Digital Enterprise Society podcast. Learn more about what you've heard here today at digitalenterprisesociety.org. Join us again next week for more connection without boundaries and creation without limits.